Today we're going to talk about properties of logarithms. These properties are something that you're going to need to know, you're going to need to be able to utilize. I would suggest just memorizing these if they aren't already memorized. So the first two we're going to talk about are the product and quotient. The product says if we have a log with a certain base and we have two factors that we are taking the log base b of, we could then split those up and say the log base b of the first factor plus the log base b of the second factor. The quotient says something similar here. If we have a common base and a division of two factors, we could then split those up into be the log of the numerator minus the log of the denominator with that same base. Both of these properties could be used both ways. So if I had the log of x squared times y, I could rewrite that as the log of x squared plus the log of y. Now, if I was given the log of x squared plus the log of y, I could bring that together to be the log of x squared times y. I could go either way with these properties for both the product and the quotient. The power is going to be a little bit more useful for us moving forward. In particular, when we're solving equations, this property will be highly useful. The property says that if we have the log of a certain base of r to the c power, we can bring that c power down in front. For instance, if we have the log base 7 of 7 cubed, we could then rewrite this as 3 log base 7 of 7. We could then evaluate the log base 7 of 7 to be a 1, and we would get an answer here of 3. The change of base formula has become less useful as our TI calculators have grown in their abilities. However, the change of base formula still can have some use to us. The change of base formula says that if we have the log base b of x, we could rewrite that as the log of x divided by the log of b, given that the log of the numerator and the log of the denominator have the same base. It doesn't matter what that base is. It could be base a, it could be base 10, it could be base e, which we're seeing there in the natural log. That is to say, the log base 7 of 6 could be rewritten as the log of 6 over the log of 7. It could be rewritten as the natural log of 6 over the natural log of 7, or we could have any other base. Let's discuss the log without a base written as well as the natural log in a little more depth. If I were to write the log of 1000, what I'm really asking here is the log base 10 of 1000. When there's no base written, we're going to assume that base to be a base 10. The log base 10 of 1000 is 3. If I were to evaluate the log of 90, what I'm really asking is the log base 10 of 90. We're never going to write that base of 10. The question is 10 to what exponent equals 90? Without my calculator, I cannot compute that. What I could do is approximate this to be some value between 1 and 2, because I know 10 to the first is 10, 10 to the second is 100. I would approximate this to be in the high 1.8, 1.9 range without my calculator. A second special logarithm that we're going to talk about is the natural log of, let's say, 9. The natural log is the same as a log base e, but we'll never write it as log base e of 9. That's the log base 2.718, etc. of 9. So the question we're asking here is 2.718 to what power will give us 9? I could approximate that without my calculator to be something around 2.1, 2.2. I know that 3 to the second is 2, so 2.718 would need a greater power than 2 to get up to be 9. We'll never see it written that way. We'll always see it written as the natural log of 9. So these would not be formats that we would see in the future. One example problem I do want to go through today would be to evaluate the log base 1/16 of 64. I have a hard time wrapping my head around 1/16 to what power gives me 64. This is where the change of base is going to be particularly useful. I'm going to rewrite this as the log base 2 of 64 over the log base 2 of 1/16. I could have chosen any base, but I chose 2 because I see 2 in 64. I also see 2 in 1/16. So 2 to what power gives me 64? The answer to that is 6. 2 to what power gives me 1/16? The answer to that is -4. I could simplify this to be 3 over -2 or -3/2. Some of you might have seen that instead of using a base of 2, I could have gotten there a little more directly if I used a base of 4. Log base 4 of 64 divided by log base 4 of 1/16. Log base 4 of 64 is 3. The log base 4 of 1/16 is -2, and I get that -3/2. This is where change of base is particularly useful if we don't have our calculator. For now, I would stick with memorizing, understanding, and knowing those properties of logarithms. The only practice problem I'm going to give you today is an application of logarithms. The application I'm going to leave you with is the light intensity at a certain depth within a lake. The relationship between the intensity of light, which is designated by a variable L in lumens, at a certain depth x in feet in the lake is given by the relationship below. 3 questions. Find the intensity of light at a depth of 10 feet. Find the depth at which the intensity is 4 lumens, and also find the intensity of light at the surface.